Just when you on this one, yeah. Otherwise.
Yeah, yeah.
Probably.
How do you pronounce Arnaud's surname? Rinquin. How do you pronounce Anna's surname? I can't see. Am I on now? One. Hello, everybody. Welcome to React Meetup. Thank you all for coming. I hope you have a good night tonight. We've got three great speakers. Tom Duncalf is speaking first. He did a great talk recently at the Functional Programming Meetup, which we all enjoyed. So he's going to talk to us. I think you'll enjoy it. And then we've got Anna next, Anna Doubkova, and then Arnaud Rinquin. So I've got a few things I've got to talk to you about. So next month's meetup, got a great venue for it, but the details are to be confirmed. June and July meetup dates are on meetup.com. For everybody that's going to the React conference in Paris, we're just hosting the drink up on the Wednesday night, so come along to that. More than welcome. It'd be great fun. Big thanks to Skills Matter for hosting us tonight, and to our three speakers. And we're hiring, so of course got to say that. If anybody wants to talk at an upcoming meetup, then please speak to Amy Becker. That'd be great. Thank you very much. Okay, brilliant. Tom, go.
Hello, can you hear me? Yes. Right, my name's Tom Duncalf. I'm a freelance software developer. I'm working with TypeScript and React mainly at the minute. And today I'm going to talk to you a bit about unit testing React applications, sort of some of the basics and some of the strategies for that. So I'm going to talk briefly about why we unit test. Hopefully you all know what unit testing is. Talk a bit about Mocha and Chai and how we can use them for testing JavaScript. And then talk about how we can unit test React components and how Enzyme can help us do that. Go through some testing strategies for a real sort of application, and then a few tips for real world usage. So why do we unit test? I mean, there's lots of reasons, but I think the main ones, we can check our code behaves and where we expect it to, and particularly with relation to edge cases and errors, which you might not otherwise test. In a dynamic language like JavaScript, you can check your code syntactically correct. So if you're running it through a compiler, if you're using something like TypeScript, then it's a bit less relevant. But in JavaScript, you can introduce runtime errors, which you wouldn't catch without the unit tests. It can reduce our dependency on end-to-end tests, running in the browser in Selenium or whatever, which are great, but they are slow and they don't necessarily pinpoint where something has failed as well. And then some sort of more abstract benefits. I think tests can kind of act as like an executable documentation for your code, and they're helpful for other developers picking up your code to see what your assumptions were. They enable refactoring with confidence. So if you've tried refactoring a code base which doesn't have any unit tests, you probably know how fun that is. And sort of if you keep tests in mind, it can actually help us write better, sort of more modular code, I think. So in terms of testing JavaScript, there are loads of libraries and tools to choose from. I mean, that's just a small selection of them. I've chosen to use Mocha just because it's pretty widely used. It seems to support all the features I want, but I think they're all good. So, it's more about the sort of the ideas behind it. So as I say, using Mocha, which functions as the sort of core test runner and test framework. So what that means is it can take JavaScript files which describe tests, and then it will execute those tests and give us the results. And so here's a simple example of a Mocha test. So we've got a file add.js, which just exports a single function which adds two numbers together. And then we've got add.spec.js, and calling it .spec.js is kind of like a convention for your test files. So then you can see we've got this describe it sort of structure. So you can describe what feature you're testing and then say what it should do. And you can have multiple nested levels of describe in there. But basically the idea is that your test will throw an exception or throw an error if the test hasn't passed, and then Mocha will handle that. So you can see like the most basic form we could do is add 1 to, if it doesn't equal 3, throw an error with a message, or we can use the assert library from Node to do that a little bit more compactly. And in any case, if that works as we expect it to, then the output looks a bit like this, just a green tick saying that it's passed. If we make that fail, so here we've added a test for adding 3 numbers together, which a function doesn't support, then you'll see, well, I can't really see it, but it's come up in red, and it's saying that there's an assertion error, 1 + 2 + 3 did not equal 6. And then it just says expected true, actual false, because all we're doing is sort of asserting these 2 things are equal. So that's okay, but it's not ideal. So we can introduce chai, and chai is an assertion library which allows us to write our assertions. So rather than using just throwing exceptions or writing the assert statements, we can use one of these 3 styles. So there's just some initial setup to sort of set it up and extract the functions we care about. And we can write either this BDD should style, they call it. So you say like function call .should.equal result, so add 1 2 should equal 3, or there's a BDD expect style, which is expect function call to equal whatever, so expect add 1 2 to equal 3. And there's also this TDD assert style where you say assert equal function call result. So I use the BDD expect style because I think it reads nicely and you don't have to have this kind of magic should appended to all your functions. And you can see that chai's got lots of different assertions, so it's not just equality. You can also test like types, length. You can do deep equality on objects because obviously 2 objects have different references, but chai will go in and check that the actual values are the same. And you can chain them together into these quite nice sort of natural reading assertions, like expect results have property addresses with length 3. So you can write quite nice tests of it. And also it gives you more useful error output than we had before. So here I've got that same thing, adding 3 numbers together. And I'm sorry, you can't really read this. I should have kept it in white. But it says here, assertion error, expected 3 to equal 6. So it's telling you what value you're getting and what value you're expecting, which is a little bit more useful than just saying true or false. So that's like very simply how we test our JavaScript. But what about unit tests in our React applications? So what are some of the things we might want to test? We probably want to test that our components render as we expect them to. And we probably want to test that with different combinations of props and states, because that's what influences our components' behavior. We want to test that our components can be interacted with as we'd expect them to, you know, in terms of clicking things to call a callback or whatever. We want to test the logic which is in our components. We probably want to test the integration between our components as well, so check that they're actually connected together correctly. We might even want to test user journeys end to end, and we also want to test other application logic, you know, things like your redux actions and reducers, which I've not got time to touch on in this, but there's plenty online about doing that. So a simple approach to testing a React component. Here's a simple component which just returns a div with hello world in it. And we can use this library React add-ons test utils, which you can npm install. And that gives you this create renderer function. And then this renderer, you can pass it some, well, here we're passing it JSX, obviously that's compiling down to JavaScript. And then we can get the output from this renderer. And what that's going to give us is an object which describes what's been rendered. So you can see here, type div, props, children, hello world. And then we can make assertions about that. So we can say type should be div, children should be hello world, which works, but it's not very sort of scalable. It's not very readable. And in reality, there's some better functions provided by the test utils, like this scry thing. But it's quite like, there's quite a lot of typing involved to write your tests. And I think if you find writing your tests is not fluid, then you're less likely to write the tests. So that's what I've found. So it's all about finding the most fluid way to write tests, which is enjoyable. So when I started testing React stuff, I used this JSX chai library, which is based on something called expect.jsx. And what this lets you do, you basically work in the same way, but it adds this assertion to chai, which lets you pass some JSX in, and then it will take the output of a renderer and compare it to what you're saying it should get. And it will give you useful error output. So it's actually quite useful, this. But the thing is, you're kind of having to test the entire result of your rendering. You know, in this case, that's simple, but I could have a component which has got loads of stuff it renders, and I don't necessarily want to test that everything's there. I might just care about certain things. So this is where Enzyme comes in, and it's an open source library from, I wrote GitHub, it should be Airbnb, and it basically gives you an API for working with the output from React components in your tests. It supports some cool features, which we'll touch on. It mimics the sort of jQuery API for selectors and DOM manipulation and traversal, so you can pull bits out you're interested in. And it works with all the major test runners and assertion libraries, so you don't have to use it with Mocha and Chai. And so, like, here's a simple example of an Enzyme test. So back to our hello world. We're using this shallow function, which is provided by Enzyme. And what that's going to do is render our component. It's actually doing something called shallow rendering, which I'll describe in a bit more detail later. But essentially, this gives us back an instance of a React wrapper class, which then has a method equals, which we can then do like we did before to assert the outputs. We can say expect wrapper.equals div hello world to be true. So it's quite nice. It reads quite naturally. But it also has other methods in there to help us just drill down to the parts we're interested in. So we can look for a child element here. We can find a div and we can expect the number of divs to equal 1, or we can look for text in there. And there are loads and loads of methods in there. This is about half of them. So you can probably find something which describes what you want to do. And then there's an extension for Chai called Chai Enzyme, which gives us the sort of natural assertion style for our Enzyme assertions. So where before we said wrapper.equals div hello world to be true, we can say expect wrapper to have HTML, whatever. Where before we said wrapper.find div to have length 1, we can say expect wrapper to have exactly one descendant of type div. And where before we said wrapper contains hello world to be true, we can say expect wrapper to contain hello world. So I've been using this. It makes your test nice and readable. So that's all well and good for hello world. But what about something a little more realistic? So I've written a really simple to-do app. It fits on one slide, sort of, but not quite. So it basically, we can just add items and we can cross them off as done and not done. So it's pretty standard stuff. And if I quickly whiz through the code of that, I'm not going to go into any detail, but we've got a to-do app component, which is going to render a to-do list and a to-do input component. And then it's got these callbacks to add to-do items to the state and to toggle items in the state as being done or not done. So we're storing everything in the state here, which you're probably not doing in your real application, but it's a good place to start. So this to-do list component accepts an array of items, and it's going to map over those and output to-do items. And the to-do item is going to render a list element, and that's going to have the actual item itself in there. And then whether the item is done or not, we're going to have a link which either says done or not done. So it's pretty simple. And then we've got the callbacks for the events in there. And then we've got the input, which just renders a form with an input and a button. And it's got this add item, which is going to read the input value and call the callback with it, and then reset the input back to zero, back to empty. So how might we test this? First of all, we're going to use Chai Enzyme, so we can create a file which loads that in. And what we're going to do with this file, I call it a test helper file. We're going to write a test script in our package JSON to run Mocha, and that's going to load in Babel. If we're writing ES6 code, it's going to load in our test helper, so that's included before everything else. I'm setting the node path because I'd like to use absolute rather than relative style imports, and then it's just going to execute all the star.spec.js files, star.spec.js star, and we run that with npm test. We can pass a grep to it to filter certain tests. And what I tend to do is keep my test files alongside the components. Some people like that, some people don't, but I will have the spec files right alongside the components because I find it sort of reminds you that the tests are there, and it makes it obvious when you haven't got a test for something. And it just sort of encourages you to keep the tests more up to date. So rendering this to-do app component. So here is our render method. It renders to-do list, to-do input. But if we would take the actual rendered output of that, then we get all this HTML, obviously, because that's what the actual browser sees. Shallow rendering is a technique where we basically just render it one layer deep. And what we don't do is render the child component. So the shallow rendered output looks exactly like the render method, essentially. So that means that when we're unit testing this component, we don't have to worry about what its children are rendering, because those children won't actually get rendered. They'll stay as the sort of component instances they are. So let's have a look at how we test that. And the main bit of a test is here. So we just take our to-do app component, which we imported there, and we shallow mount it. And then we can just say, expect it to have exactly one descendant to-do list, and expect it to have exactly one descendant of to-do input. and we import those there, obviously. And that's basically it. I mean, that's probably all that we care about in terms of rendering on there. We don't care about the div. So that's how simple it can be to test rendering of things with Enzyme. And if we move on to the to-do input component, it's basically the same thing, except here we're rendering input and button HTML elements. So we can do the same thing, except when we're mentioning an HTML element name, we have to include it in quotes here. So we're saying expect it to have exactly one descendant with a tag of form. And then what we can do is use .find to drill down into those elements, and it will give us back another React wrapper. So we've still got all the same API methods available. So we can say expect the form within the wrapper to have exactly one descendant of type input and exactly one button. And again, that's probably all we care about for rendering of this. You could include the copy in there, but copy tends to change, so maybe it's not worth having in a unit test. And if we were to have an error here, just to show you what the output looks like, so I've removed the button there, but it's still in the test, then it will give you this output saying expected the node to have one descendant button, but actually found 0, and it'll give you the HTML that it found. So it's quite useful for drilling down into what actually failed. So like slightly more complex example with to-do item. So this is taking an item from its properties and it's rendering that out. So the only real difference we have here is that we need to pass in the item when we're passing it into shallow. So here I'm passing an item with an item property of test, and then I can just test it in exactly the same way. So I can say it should have one li inside it, and that li should have one span inside it, and then I can chain together the finds to say that li should have a span inside it, which has the text test, and likewise for the link, I can test that that's got the text done in it. And one improvement I'd make here, so it says it should render correctly. That's what I've named my test. But coming back to the thing about tests being sort of executable documentation, this is like an edge, not exactly an edge case behavior, but we've decided that if there's no done property, the item should be marked as not done. So what I'd do is use the test name to describe that. So then the next developer who comes along knows that that was the intended behavior of the system. So that's something I always try and do, is make the test name a bit more descriptive in these kinds of cases. And then we probably want to test a few permutations of this for the different values of a done flag. So what I've done is extracted out all the assertion logic into a function, which takes a wrapper, the expected bits of text, and then I can just write loads of different permutations of it really simply like this, and if you're, even for a more complicated thing, because I've extracted it out into this function, the tests are really short, and if the markup changes, I just have to change the test in one place. And we could modify that so it takes a Boolean flag instead of a string, and then we can test that it's got a certain CSS class on it. So this is another one of the things Chai Enzyme gives us, so we can say expect it to have class name of whatever. So I think it gives you like quite nice readable tests really. And then the final rendering one is our to-do list, and the difference here is that it's got this onItemDone callback, which we are binding when we render it. So if you don't pass that callback in, bind is going to fail because you can't bind null because it doesn't have a bind method. So what I've done here is created a function which is going to return me the wrapper with the list of items I give it, and we're just going to give it an empty function as the callback because we don't care about the callback in terms of rendering. And then I can pass it an empty list and say it should have exactly one UL, and that UL should have no to-do item descendants because remember it's shallow rendered, so we would see the children as to-do items rather than LIs. And then I could likewise test it with 2 items in there, and I can use this .at method that Enzyme provides to get the first or second item out of ones it's found, and then assert things about that. So here I'm saying that its item property should deep equal the item that I passed in. And that's essentially it for like rendering tests on this. So hopefully, like if you've not used Enzyme before, you can see that it's got quite a nice clear syntax and the tests are nice and readable. So in terms of testing interaction, this is the to-do item again, and we've got this anchor, which when we click it is going to call the onDone callback. So what we want to do essentially is click that and then check that we've clicked it. And we can do that using, well, so the React wrapper that Enzyme gives us has got a simulate method, which will simulate things happening to the element, for example, clicking it. And we can use a library called CNON, I think you pronounce it, I don't know, which gives us something called spies. And a spy essentially can wrap a function and then log every time we call it. And then afterwards, we can make assertions based on was it called with certain values. So what we can do here is pass in a spy as our callback, click the link, and then verify that the spy was called afterwards. And that test would look a bit like this. So you'll see I've split it out into its own describe block. So we've got to-do item as the top level, and I've got all the rendering tests, and then all the tests to do with clicking done, for example. And it's as simple as creating a spy, This is just an empty SPI, so it's not wrapping any function. It's not going to do anything. Passing it in to my props. And then I use this simulate method. So I find the link, I click it, and then I just expect that my SPI has been called once, and that test will fail if the SPI hasn't been called. And then likewise for the to-do input, there's a slight difference here in that this uses refs to get the actual DOM node related to the input, and then it uses the .value property to get its value. So this means we need to interact with the DOM, and when we shallow render components, we don't have a DOM, so we can't do that. So what we're going to do is introduce something called JS DOM, which is a JavaScript implementation of a DOM spec. So it's kind of like a virtual DOM we can use without having to actually run these tests in a browser. So there's a little bit of setup we do for that. I won't talk through it, but essentially we're setting up a document and we're exposing its window and its document globals, which are what the test and the code is going to interact with. And then we can just write our test. So what we're going to do is mount our to-do input, passing in a SPI as our callback. And we're going to find the input, set its value. So we're using this .get here, which actually returns the DOM node in question rather than the React wrapper to the DOM node. So we're operating directly on the DOM node there. And then this is a bit clunky, but this is the best way to fill out a form I found with it. So you have to set the value, simulate a change event, and then submit the form, which I guess is one of the downsides of working with a virtual DOM. Not, you can't just type in it and click it. But, well, maybe you can. I couldn't get it to work. But when we submit that form, anyway, we can check that our callback has been called with the value we expect, and we can expect that our input element's value is equal to empty string. So we've reset our input again. So like, despite the slight clunkiness about filling in the form, I still think that reads quite well. So the final bit we've not really tested is that everything actually joins together properly and that we're adding items to the list and marking them as done. So if we remind ourselves, we're doing that by setting things in the state and then changing things in the state. So one approach you could do is to mount the component, and then we could extract the callback for adding an item. And then we could look inside the state, because Enzyme gives us access to a component state, to check that it equals something. And you could do this for like adding an item. We could pass in an initial state as well. But that's kind of testing the implementation details of the way we've done it. And that's not actually what we're interested in. We're interested more in testing that the component does a certain thing rather than that it puts certain things in the state. So a better approach here, I think, is to sort of integration test the component. And we could do that using mount rather than shallow. So what mount's going to do is fully render it with all its children and let us interact with it. And so if we do that, we mount our to-do app, and then we can just do like we did in the to-do input test and fill in the input, submit it, and then we can say, I expect it to have exactly one LI descendant, so we've now created a new item, and then I can get that item of a React wrapper for it, and I can say it should contain the text test1, and it should contain the text done. So that's essentially like integration testing our whole application there by going in and actually messing with the DOM. And we could extract those out into functions again, and then we could have a test which adds multiple items and asserts it without ending up with a really long function. And so that's kind of essentially it for this app. Oh no, oh yeah, and we can test marking items done as well. We can click things and it should make the item done. And this allows us to change implementation details and kind of check that everything's wired together properly. But chances are your application isn't that simple. And one thing you might have in your application is you might make use of Redux on some of your components. So you'll have your smart components, which are connected to Redux store, and some components which aren't. So if we were to convert this into Redux, so essentially what I'm doing is just wrapping the to-do app in a provider, got a simple reducer and action creators here, which do what I used to do with state. And then my to-do app component is now connected to a Redux store, and it is getting its information from the state, and it's calling actions on the state. So if I try and run my tests now, they all pass except the to-do app ones, and they're failing with an error which says, invariant violation could not find store in either the context or props of connect to-do app. So what's going on here is that when we normally run our application in a browser, we're starting with index.jsx or whatever, and that's going to create the store and put it in the context, and then any components which connect to a Redux store can get that store. But because we're starting just from this component, there's no store there for it to interact with, and so it fails. So one approach we can do is that we can export the non-connected component from here, and we can test that with shallow rendering. So here's like my code. I've got the to-do app, which I'm then wrapping, or I'm then turning into a higher order component with connect. I could export that separately, and then I can write a test which, so you can see here I'm importing the connected component as decorated to do app, and then I'm importing the non-decorated component just as to do app. And then this test would then work again, which is shallow rendering it and asserting its descendants. So that's kind of useful, but it doesn't let us integration test it. And so the approach I've been taking with this, I don't know if it's the best one, but is to create a real store and put that in your context. And then when you mount the application, it's going to actually get that store out of the context, and it's going to actually work with a Redux store as you'd expect. So I've got a get wrapper function which creates the store and puts it into a context object. And then this second parameter of mount in Enzyme lets you pass in a context. So now my component has got this in its context, and you need to add something to your component to say that it will accept the store as one of its as something from a context, which, yeah, you just got to do it. And then I can test it as I did before. So I can, now that it will mount, or my test will pass again. So this is kind of what I've been doing for integration testing things, which, I call it integration testing, but we're not necessarily doing it from a top down. It might just be like a subtree of components that we're testing. And one of the advantages here is that we can actually keep hold of the store we've created as well and return that alongside our Enzyme wrapper. And then we can do interesting things with the store to kind of create these like hybrid tests, which are kind of unit tests and kind of integration tests and kind of end-to-end tests, but can go directly into the Redux store and do stuff. So like, I've got an initial state I can pass in, so I can initialize my component with a certain state and then assert that the DOM looks a certain way. Or I can create my component and take the store and then dispatch actions rather than clicking through the UI. And then I can assert that the DOM looks a certain way. And I've actually found this is a really powerful approach for testing stuff when compared to using like full end-to-end tests. So like I find it's quicker and more reliable, and it lets you sort of take shortcuts where it makes sense, you know. So if I want to get to a certain point in a long flow, I can just dispatch an action with the fixture data that I need, and then I can interact with the DOM and see what happens, and it'll run in like 100 milliseconds rather than 10 seconds or 20 seconds, whatever a Selenium test takes. So I'll just quickly show a couple of examples from like real stuff I've worked on. So like here I'm testing that when you're on the settings page and you submit an email address, that it posts a request to the back end. So what I've done, I've mounted my component, and you can actually, I'm passing in the history there to start off on a certain URL with React Router. And then I'm using something called fetch mock, which mocks the global fetch function and lets you define how it should respond to certain calls. And then my actual test, I can say like just mount my component. We have to do a set timeout 0 just to wait for the fetch to actually occur. You know, it's like requeue our call at the end of it. And then I can interact with the DOM, set the input, click submit on the form, and then I can check where it posted the data. And so you've kind of got a hybrid there between a unit test and an end-to-end test. Or another example here is where you've got like a flow which goes from step 3 of a form to step 4 of a form. So I can mount my wrapper with initial state saying I'm up to step 3, and I can check I'm on the right page. And then rather than going through the UI to fill in details, I can just dispatch an action with that, say go to the next step. And then I can check that I'm on the right step by looking for the component. And then I can assert, for example, that my analytics tracking thing has been called. So like in the application I'm currently working on, there's quite a lot of complex flows through sign-up journeys and stuff. And I've been taking this approach to sort of testing all the permutations and then using Selenium tests just for the main sort of happy path and like the real critical error scenarios. And I've found it works quite well. And so finally, just like a few quick tips for real world usage of this kind of stuff, because obviously those examples are tiny. So you've got to work out the right balance of unit and integration and end-to-end tests, and realize that those boundaries aren't necessarily clearly defined. You know, I don't think you can be too kind of religious about unit tests being strictly contained to a single unit, because sometimes it's more useful to see how we integrate with certain bits. And there's actually this concept of a testing pyramid where you've got like lots of unit tests, quite a lot of integration tests, and then a few end-to-end tests. And that's what I've found works well, because end-to-end tests are slow to run, they're kind of brittle, they can be quite painful to write. Integration tests are easier to write, but obviously you're not testing everything, you're not testing it's deployed successfully, that kind of thing. And then unit tests, you know, covering everything else. So you can end up with quite a well-tested application. Ensure your test names are descriptive and the tests express what they're doing clearly, either with comments or like working out, like if you're adding together some numbers, sometimes I'll write it as like 1 + 2 + 3 rather than 6 in the test. So then the next developer to pick it up can figure out what was going on there without wondering, where did this magic number come from. Make liberal use of functions and fixtures. So rather than putting all your steps in line, like put them into functions. So if the code changes, you can easily change your tests to match what the app's like. Use mocking and injection where it's required, but I think you can keep it quite simple in JavaScript. You don't need DI containers and all this kind of thing. Like one approach I've been taking is when you're testing a function and it depends on another function which you want to swap out, then just pass in the actual implementation as the default argument. But when you're testing it, you can pass in your own implementation which you control. And finally, there's a few useful libraries if you do try out this combination. So try as promised lets you work with asynchronous tests really easily. You just return a promise from your test effectively. Try date time lets you assert things about date times. Fetch mock lets you mock the fetch thing, as I showed before. So you can say, like, check certain calls have happened, return certain things from certain calls. And timekeeper lets you mess around with the system time, which can save you having to inject times for everything, which is quite nice. And that is everything. So there's some links here to this presentation and the code that I showed and the tools there. And my contact details, if you've got any questions and you want to contact me, I'd be happy to help. And if anyone's got any questions now, I'd be happy to answer them. No?
That was brilliant. Thank you very much.
Cool. Thank you very much.
Really good. I'm sure there's lots of gaps there that have been filled in, which is great. Thank you. Really good. So Anna's next up. Are you ready? Or do you need to? Brilliant. Tom, you got off lightly there with no questions. Well done. That was really good. Awesome.
Entire screen. Yeah. All good? Yeah? Can you hear me? Awesome. Hi, my name is Anna Doubkova. I'm a software engineer at Red Badger. And in my current project, we're working at this CMS that we're doing just for 3 months. We are supposed to leave at some point as developers and leave our client with the CMS that we made for them. And we were thinking it would be really nice for them if they could just modify the CMS by modifying their data structure without having to get other developers to come in and extend the CMS. So that's how we figured out that we could create some sort of dynamic forms system. So there would be forms that are driven by data and by our data structure. So as an example, you can imagine that as an SEO manager, I would like to add some redirects to our system. And normally I would just need to add the original URL and the destination URL. But maybe I would like to later on add the type of redirect. Maybe I want to just do some temporary ones for a moment. So instead of going to the development team and asking them to like add stuff in the CMS and like go through the whole pipeline of deployment, etc., it would be much nicer if I could just go to the database and add a field there and automatically render the form in the CMS with using this data without having to go through the deployment cycle, which is much more effective. For this project, we're using Contentful, which is quite unfortunate for us as developers, but it's very easy for the managers or their tech people to just go to Contentful and add a type like this. So that's why we decided to do something similar. In terms of technology that we decided to use, we obviously chose React because we love React. We also decided to go for redux-form. The reason for that is that we're using Redux a lot in our applications, and redux-form seems to be like the sort of standard for using forms with Redux. It's not perfect, but it's pretty good, and it does a lot of things out of the box. And for connecting the database and the UI, we decided to use JSON schema, which is kind of like a typical solution for this problem. Let me start at the beginning with JSON schema. This is where we had to start when creating the dynamic forms. It's fairly obvious why we chose that. First thing is that code generally supports JSON. You can choose any platform or any coding language, and they probably have some sort of support for JSON. The other day, I found out that there is a JSON support for Photoshop. You can script your Photoshop with JSON, so apparently you can use it absolutely anywhere. And the reason for JSON schema itself is the fact that it's pretty universal. You can use it across a lot of different apps. You can use it in like different libraries, etc. It's quite generic. You can define anything in JSON schema. So in case you want a form or maybe some extended version of it, or maybe just describing the data structure, you can do it all through that. And last but not least is the fact that there are a lot of libraries that help us with validating data against JSON schema. And that is something that helped us a great lot because we completely skipped the hassle of doing any validation for our forms. So this is a basic schema of the form that I showed you before. This is just whatever JSON schema would give us. So there is a title of the form, and as properties are the fields of the data and later on of our form. And we also specify which fields are required. So this is really very basic, which would be enough to render some sort of UI, right? Like you could actually render a form from this, but it would be a very basic one. And we decided that we would like to use different editors or different inputs for displaying the fields. You saw the radio input. We are using currently Draft.js, which is amazing as well. So there are a lot of different ways of displaying the content, and we would like to have this information in our JSON schema as well. And then there are some like other obvious things like description and labels and error messages if validation fails, format for validating, etc. So we decided that we actually do need to have something more than JSON schema would give us sort of like out of the box. So as you can see, we added the editor, which is just the name of the React component. We added description, which is the label, error message in case of the validation failing. We also added labels to the redirect type so that we can display the radio inputs with the correct values and correct labels. And yeah, that's pretty much it. This is the simplest and shortest schema we have in the CMS at the moment. So as you can see, it would be quite a hassle to write that manually. So we actually generate these schemas from the content types in Contentful. The reason we chose React is one that I guess I don't need to justify at a React meetup. It's awesome. It's easy to use. It's great for dynamic things, right? Because you just have components and you just compose them based on some data. So it's a really great thing to use at this case. We had to build a few React components, but not too many. I would say all in all, the basic code is about 200 lines. So that was really, really quick and effective. So we have the form that just like renders all the input fields. Input field decides which editor to show and maybe just like a fallback to single input or normal input text. And we also had to write a dynamic form wrapper, which is more like the already redux form part, which is something I'll be talking about later on. And here we are with the code examples. So this is the form. As you can see, it doesn't do that much. It just renders a form and a button for submitting, and it renders input fields. There are quite a few things that already come out of the box from Redux form, such as the submitting and validation. At the top, you can see that we are submitting the form only if it's valid, and then we reset the form. This is something that comes from Redux form. We didn't have to write anything for that, which is pretty nice. One thing that I would point out here as well for the input fields is this part here. The fields come from Redux form as well, and they contain a lot of information, like whether there is an error in that field, whether the field has been touched. It has about 30 properties. I don't even remember them all, but this is the way we actually link Redux form to the actual value of our input. The input field itself is really simple. As I said before, we are choosing the editor. If we have the correct editor that is specified in the schema, we render that. Otherwise, we fall back to some basic input. And in here, we also decide whether to show error. And that, again, comes from Redux form. So again, nothing too complicated. As an example of an editor that we are using, I chose the radio input because it's relatively complex, but not too complex. At the top, we are just checking whether the enum or the values and the labels have the same length. That's just to check that the user hasn't made a mistake, because we're generating the schema from two different things. One is the content type and the other one is the extension. So the labels come from extensions, the values come from the original content type. So we need to just check that they specified everything we need to render the form. And then later on, we're just rendering the buttons itself. We have the first one checked by default, and we just render a label for it. As you can see, there's the field with spread operator. That is the part where we actually link the input to the state. That was a tricky part because this does everything out of the box for you. This is it's like magic, but it's not entirely well documented. So it took us about 2 days to figure out how to actually link it. And it was one of those cases where you just write 8 characters and suddenly everything works. But it was hard to find that out. And one more thing that I would like to point out here is the fact that we have to use the React default checked here for checking the checkbox, whereas you would maybe expect that the initial value of the form could check it for yourself, but no, you have to do it on your own. So the initial values of Redux form kind of work and kind of don't. So sometimes you have to sort of tweak it to make it work 100%. And now finally for Redux form, or the interesting bit. We started by creating a wrapper, which might be weird because we already have a form component, right? But the idea is that Redux form also connects the component to the state, which is kind of weird, kind of black boxy, because it wraps something that it doesn't necessarily need to give you. But anyway, it does. So that's all right, I guess. So yeah, we get the form as a form component, and we put it inside another component. So basically what happens here is we have the component form that you already saw. We connect it with Redux form so that it gets all the things like connecting to state and on-change handlers, etc. And then we wrap it in another component that just gives it the schema and the initial values, and it defines the fields so that the form knows what to render. This is the second part of the same dynamic form component, the render part. As you can see, it just renders one component, which is fairly simple, and it gives it a lot of things. Some things are required by Redux form, such as fields, which is just an array of names of the fields that we want to render. Validate method just validates. That's something that we had to write ourselves, but Redux form automatically validates every single field whenever we change something. So we don't have to do anything for that, at least. We can pass it some initial values. So as you can see, we sort of have to again, go through all the fields, check whether there is a radio input, and if there is a radio input, we actually have to select it here as well and pass it into the state. So that's kind of unfortunate that you have to do it twice. However, if you are using just like normal text field, it does it on its own. So sometimes redux-form is really clever and does everything for you, and sometimes you have to do it yourself. Then there's a lot of stuff on the form container that we don't really use anymore. And the most important is the schema, which actually renders the input fields for us. So all the code that you've just seen is all the code that we actually used for rendering dynamic forms. So that was quite simple, right? It wasn't that much code. It wasn't that much things to write. It was a lot of things to learn and find out how redux form works. But once you do that, it's really simple to create a very dynamic CMS that our clients can later on use without us having to step in and do extra work. From experience of working with redux forms, there are some really amazing things about it and some things that were really annoying us a lot. I'll start with the bad things and go on to the good things. The worst thing for us was the fact that the docs are really insufficient. It was sometimes very, very hard for us to actually figure out how to do things. You have a lot of examples on the redux form website, but they don't quite often cover everything that you want to do. Sometimes the information there is incorrect or just doesn't really describe everything that you would need to know. So I spent a lot of time just going through the code of redux form and trying to figure out how things work from there. It's kind of black boxy, as I said. It sort of like covers a lot of things under the hood, and you kind of have to rely on it working. You can't really get in there and just like change it yourself. Another thing is that the performance, especially with big forms, isn't great, and you can actually get around that by using component should component update, one of the two. So that's not a problem that you can't get around, but nevertheless, it's something that you would kind of expect it to deal with. One of the things that some of my colleagues didn't like is the fact that it hijacks on change events, and it does like really a little bit too much. Like every single time you type something into an input field, you see like 4 or 5 different actions logged in Redux, which is just like a little bit too much. It could be a little less. But that was really all the bad things, and it's more like, I feel like it's more like nitpicking, because really redux form does so much that it heavily outweighs the cons. The best thing, obviously, is the fact that it just connects automatically the inputs to the state, and that whenever you submit a form, you already know whether it's valid, you know exactly the values that are there. So it does a lot of things for you. And if you've ever created a form where you had to write the validation yourself and all these things, you probably know that this is really, really cool. Another thing, although I said that it's a bad thing, it's also a good thing that you have all these actions of the user, the way user interacts with your form. You always see that in the logs, and you always see that in the actions. And although we didn't use that, you can even obviously listen with your reducers to those actions and change state of the whole app based on what the user is typing in the form. Not sure if that's useful, but it's nice nevertheless to know that you can actually tap into everything that is happening with the form. As I said, there are a lot of out-of-the-box events, so you don't really have to worry about much about writing. Most of the things are just there for you to use. The field thing, we didn't really find a good name for it. It's just the fact that you can connect the input to the state automatically just by typing field. It's pretty nice. And yeah, obviously the fact that the state gets automatically updated every single time you type something in. So it literally does everything for you that you might need. A few notes to conclude with, or to just like sum up our experience. It was pretty good overall, at least for me. Maybe the other developers on my team wouldn't agree, but I had fun. It was an interesting experience, and at the end of the day, when you find out how this whole thing works, It's really, really easy to use. And right now with the structure that we have, it's really simple for us to create new components. We created a whole edit page, like a really major thing within a few days, maybe like within a day or two, which was really nice, just thanks to having this thing in place. And another really awesome thing is the fact that version 6 of redux-form is coming out now. The version alpha actually came out today, and it's completely different. Like, you can forget everything that I said today. Anyway, it's just like the first spec, right? So it's gonna probably change a little bit, but it does a lot of good things. It solves a lot of problems that I already talked about. They wrote a whole new website with the documentation and examples. So overall, it seems like Eric Kress is working on it, and he is very active in trying to solve all the issues that are reported by the community. So that's another really cool thing. And just to go through our solution once more, we use JSON schema to describe the data structure and the UI, so that then we can render the UI for the user automatically without a developer having to come in and change the CMS. We used React components because they are extensible and composable, and we use redux-form because it's pretty cool. That's it for me. We're from Red Badger. We're hiring, I have to say that as well. And yeah, if you have any questions, I'm happy to answer them.
Really good presentation. Thank you very much for that.
Thanks.
I have a quick question about the validation. How easy would it be to add some conditional validation? So, we have two different fields and you validate one depending on the values in another field, a little bit more, kind of business logic in that layer.
Well, we didn't do that specifically because with JSON schema, you can do it actually. In JSON schema, you can still define relationships between different properties. And there are quite a few libraries that just take JSON schema and compare the data against that. So although I haven't tried it, I'm fairly positive that it would be sort of out-of-the-box solution as well.
You just get a function which it's given your values, and then you can just do what you want and return true or false from it, and you can even do async validation. Hi. So yeah, I've been working with redux-form for ages. Well, in the React universe ages, and yeah, you did a great summary of it there. I was just wondering, did you compare it to any of the alternatives out there before you started using it?
We tried to, especially because you pointed out that there is an issue with performance. But then in the end, we realized that it's just nice because it's widely supported and widely used. So probably if we have a problem with it, somebody else has already had that problem and it's solved. And yeah, I'm really positive about the version 6. I'm very happy about that. So it's sort of one for us. Yeah, I guess that's it. Somebody else? Oh, yes.
Handily all sitting together.
Thanks for the talk again. It's very useful. I think one of the downsides that I found in the redux-form was that it's not recognizing automatically HTML5 validation in the markup, which probably would be a good thing to do for me. Oh, what's your take on it?
Sorry, which foundation?
So for example, if you do input type email, I'd like it to recognize it straight away.
I guess we didn't really mind that because of the JSON schema, because they sort of did that for us. We had also a lot of issues with normalizing the values for so that they are actually the right thing. So for example, if you have input type number, you still sort of have to normalize the value so that it's not a string. So yeah, that would be nice. That would be nice if it was out of the box. I'm not sure if that's in version 6, but I think it would be good if that was a part of it. Thanks.
Thanks, Anna.
Someone in the very back.
Oh, sorry. We're gonna have a break in a minute for beer. The bar's open downstairs. Free beer.
Sounds great. Thanks for the presentation. Really interesting, and there's not enough people talking about forms in React, so it's good to see something out there. I had some experience with something called Formsy React. I don't know if you can compare the two or if you've experienced that at all. I haven't touched redux-form, so it's hard to know how they compare.
Right. No, I've worked only with redux-form, so I can't really compare those two. Maybe Tom can help you though on that one. He has worked with everything. Okay. Yeah. 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 So just to sum up on that, we both kind of came to the conclusion that Redux form is more advanced, mainly thanks to the connection to like Redux state. For me personally, it was just like a winner because it's a big one. I kind of like well-supported things. Yep.
Right. Okay. Brilliant. Beer time. Don't pay for the beer. Make sure they give it to you. Make sure you've got your sticker. 10 minutes, and then Arnaud's going to do a talk. He's got some great ideas he's going to share with us. So, come back. Cheers.
The other side. You know what? Like, I've actually figured out how to run tests without it. Well, all right. Okay.
Our last speaker tonight is Arnaud. Great introductory slide. I'm sure it's going to be a great talk. So there's some great ideas in there. And then afterwards, we're all going to the pub across the road, so come join us. Don't forget to join us on the Wednesday before the React conference on the Wednesday evening. The React conference is on Thursday and Friday. And I think, am I allowed to say that Christopher Shadow is going to give a talk at the React Meetup on the week before? No. I'm not allowed to say. Oh. in the June Meetup, which is good. Cool. Okay, Arnaud, go for it. Thanks.
Hello. Thumbs up if you can hear me. Okay, sounds good. My name is Arnaud. Tonight I'm going to talk about unit testing. Again, another talk about them. But this time I'm not talking about how you write them, but I'm going to talk about how you set them up, all the tooling around them. Basically, setting up tests is a pain. You need a test runner. You need to bundle your application in many ways. I find the tools to be a bit bulky, and I had a few ideas that could make things a little bit better. So your probable workflow, I'm not saying you're doing that, but that's probable. First, you spend hours setting up a tool chain with a module packager like Webpack or Browserify, and then you have your ES6 with Babel or TypeScript or whatever, and then you've got your CSS built by, I don't know, Post CSS, SAS, whatever. Then you had minifications, and then you had a test runner, which must understand like the source maps and all the things, and then you want the watch mode, and okay, that's JavaScript fatigue, right? It's not easy, but once it's done, it's done. And then your workflow is you write some stuff in a file, and you probably write stuff in a test folder, or you write stuff.test.js or stuff.spec.js, whatever. And then you generate your bundle, app.js, and then your test.js bundle with Webpack or Browserify or Rollup or you name it. And then you run your application in the browser, usually with a live reload. And you run the tests bundle in Mocha or Karma or Ava or many things. And then you check your browser if there is any obvious bug, if the application renders or not. And you check your test runner to see if there is any test failure, like Tom just showed. And then you repeat. That's the TDD workflow. Okay, and then you want to debug your test, and it's hell because the tests don't have the source maps or yeah. And I had a couple ideas, and it all started with Dan Abramov again. And I was watching the screencasts for Redux on Egghead. Awesome videos. You should check them if you haven't. And then I realized he was writing. Can you see my pointer? Yeah. He was writing tests, and just below he was writing so he was writing code, and just below he was writing tests. This seems like the easier way to write code, like code, test, and you've got your console open and you see if the test pass or not. Awesome. I would like that on my workflow. And I realized, wait, this left side of the screen is actually something you can achieve easily with Webpack Dev Server, having your code compiled and run and refreshed every time you type something or save a file. And the other side is just your browser console. So it can be any browser. That's awesome. This is actually something you can achieve. So what I want is like spend a little bit of less time setting up my toolchain. I still have to have the packager, the ES6, the CSS minification, but I want to get rid of the test runner because I can run the test in my browser. Okay, I still want the watch mode. So I want to write stuff But I don't want to have another file for test because, well, if I can have the test and the code in the same file, it just makes it easier, and it's more like give me an incentive to write them. And then I just want to generate one bundle. That's plenty enough. Not write test bundle or having two bundler running together. And then I just want to throw my application in the browser, and that's it. And I want to see in the console if test is failing, and that's it. So I'm going to show you a demo of how I can do that. So if I open this, can you see that? Yeah. Okay. This is some sample code here. Here I've got my component which does nothing useful, just renders random crap. But here I've got my test. My tests here. I'm using Enzyme, a really good library. Go for it. And I'm using Sinon as well. And just below my stuff, like I can have my tests using Enzyme. Here, my test framework is tape. It's simple. It works. Just try it if you haven't. It's pretty good, but it doesn't matter. And here, I'm going to restart this. I'm going to npm run dev, and what it does is I'm just starting Webpack dev server with my usual config. And because I've got tape and everything here, I switch to my proper tab. It's going to load. If I open my console, well, is it readable enough? Well, I've got my test results in the console. It's not amazing, but I've got my results, and the pain I had setting that up is none. I mean, it just runs and give me a result. Back to the slides. Okay, just a GIF of like in case my demo failed. And the problem with that is you can't do that because you can't ship that kind of code for production, right? Because you can't ship tests for production. But that's why we usually separate test and code. But we can actually, with this Babel plugin with an incredible name that I've written, it lets you target on the left side, right side. You can see I'm targeting the tape module here, and that is whole. This is the whole config, like just a npm package and this blob in your Babel LC file. And I should go in presentation mode for the animations. Yeah, okay. So because I target the tape thing, my Babel plugin will look for all the imported stuff, then look for when it's actually used, and it will actually get rid of them. So the idea behind this is that for production, you just remove all the tests, and in dev mode, you just bring them along and run them in the browser, as you would do, well, as you could do if you were not caring. So I'm going to show you live as well. If I run the application in production mode, which you can see here, you've got this node env production. Oh, it's gone already. No, it's still there. And I'm going to refresh my page, and it takes a little bit of time, but yeah, there's no test because the payload is like super slow, super small, and the test and all the test libraries are gone. And I don't have to think about removing the test. And it's actually a little bit more clever than everything, because you might think, oh, but you're using tape, okay, and you're removing tape and all the tape code. But what about Sinon or like this expect library that you're using or Enzyme? Well, my library will be clever enough to, well, first remove the tape thing, and then, oh, expect is not used anymore. So you just get rid of it. So by just targeting my test framework, in this case, it's tape, could be anything that you import. I actually remove all the test-related stuff, and my bundle becomes just as small as possible, just the useful code. Of course, you can whitelist bundles or module if you need to. In our case, you're using React most likely, and you need to whitelist React because the JSX parser will run after the Babel plugin. So the React will not be used until after my plugin runs. So, well, whatever. You need to whitelist React. Okay, so far we've got tests written just next to the code. It makes it so much easier to get started with tests. Like usually the hardest problem is you get started, you write some code, and well, we'll see later for the tests. Here you can just write them just below, it's easier. You run your test in an actual browser, which change all the things. I think JSDOM is a nice thing, or Phantom.js is a nice thing, but there is nothing like an actual browser. You've got the results in the console. It's not ideal, but you'll see later. And for the production, you drop your tests and you ship the smallest bundle, and all that was done by just using one Babel plugin and targeting your test framework. But you're not impressed. It's not enough. It sucks. The next step is browser tap. Yeah, 3 lines of code. Well, actually, what this is just a wrapper around the tap framework, which looks for the window.tap extension function and use it and calls it if it exists. Otherwise, it just returns the tape module. Just that. But what it lets you do is demo 2. So I'm going to go back to my code here. I'm going to restart the server in dev mode, so the regular mode, and I'm going to enable the Chrome extension that I've got here, and I'm going to restart. Oh, I need to close that. I'm going to restart that and open that and open this tab. And now I've got all my tests running in a nice, it's not big enough, but a nice DevTools panel. And I can enable some notifications, and I'm always on. And I'm going to first restore a few tests that are not commented out. I'm going to restart. And up, because of Webpack and Live Reload and everything, I've got my test, I've got a nice notification, I've got everything pretty. I'm using the, well, actually, it's just a copy of Redux DevTools. But I'm using, like, you can see the expected and actual results. You can interact. One of the biggest issue you might have with that is that, okay, well, I'm going to develop my application and save a lot of times, and I'm going to have thousands of tests, and every time I reload the application, it's going to take too much time for all the tests to run or anything. But I can just switch on and have control over my tests by just switching off auto run. And if I refresh my page, it doesn't run unless I click somewhere and run the tests. So it gives me first a better output of my tests, and it gives me control over running my tests right in the browser. And it's just a Chrome extension. It's not a library and the thousands of packages to set up and scripts to run. Yeah, good. Back to presentation. Yeah, just a GIF in case my demo failed. So what you've got now is if the extension is there, you notice that I just restarted the test, but it's just a matter of having the extension enabled, available. If the extension is there, I've got control over my test and I display the result nicely. Otherwise, it just falls back to tape. So far we've got tests written just next to the code, easy tests that run in an actual browser, and result that runs in the DevTools, and control over the test execution, which can be really handy if you've got many of them. And you can just drop them for production. But you're not impressed. So the next step is is the last one. What is missing here? Well, you probably work with continuous integration or something, and you want to test the test run and produce results from the command line, not from an actual browser. And you might have noticed that I'm actually just running my application in a browser. And there is this clever thing called browser run. It's available on NPM. And if I just here, NPM test, test, I'm gonna actually call and throw my whole application into browser run, and it will run the tests in Electron or another browser if you want it, and produce the output in the console so you can run them on Travis or whatever. And the whole cost of the thing is 0. It's just like you copy the test script and put it, and you've got your CI test running. So browser run, basically you've got to build your application using Webpack. I'm using Node-env CI here. Then you cat your index file, you throw it into browser run, and here I'm piping into TapSpec. I don't know if you're familiar with test anything protocol, but it's just something that displays the results in a better way. And you've got to have this bit of code here, which says if your environment is continuous integration, then when the tests finish, close the window, because otherwise Electron wouldn't know when the tests are finished. It waits until the tests are finished to close the window. And then you've got a nice output of your test in the terminal or in the continuous integration, Jenkins, Travis, Circle, whatever. So you simply run your application in any browser, and you get the result in the shell, and that's about it. So just a summary: you install a Babel plugin. You target your test framework, tape in my case, and you install a Chrome extension. And what you get, you've got code and test next to each other, and you don't have to think about it. You've got test running in any browser because, well, you just throw your application in it. And you've got like a proper TDD workflow, like it just reloads every time and you don't have to think about it. You've got a nice UI for test results right next to your usual dev tools, which is nice, better than having, I don't know, something else running elsewhere. And you've got CI testing for free. No hassle with Phantom.js or the caveats of JSDOM or anything. So what's next? Well, I've chosen Tape because it's a browser-friendly test framework. Like all of the others, they put some globals or they rely on Node APIs. But actually, it's not that easy. Like Tape is not browser-friendly natively. You've got to compile it with Browserify so you can import them in Webpack. Well, that's a mess. So probably rewrite or do something like more generic. I don't know. Maybe write the adapters for the extension for other test frameworks. Could be handy. Like if you like Mocha or Chai, which are really nice as well, that could work. Have more control over the test cases, like being able to focus or skip tests from the UI or rerun just one test. That would be nice. Or maybe because you're refreshing your application often and maybe you just want to make your application like still available and usable when your test runs. Just maybe throttle them so they keep running, but one every 100 milliseconds or something. A better name for the Babel plugin. It's too long, but it does actually what it says. And the extension has not been released yet on the Chrome store, but I'm gonna do it soon. That's it. Thank you. Got any questions?
Has anyone got any questions? That's brilliant. I mean, well done. There's a lot of hard
Thank
work
you.
gone into that. Everyone's going to play with it, I'm sure. And there's some good ideas in there, so thank you very much.
Everything is available. Just give the URLs and that's it.
Cool. Thank you. Okay, to the pub. Let's go. Thank you very much. See you next month. Oh, thank you very much to CodeNode and to Skills Matter and for hosting and Red Badger's hiring. And we'll see you next month. Cheers. Bye.